Good afternoon. Thank you everyone for having me. And yeah, I've got to admit, the running order has been almost perfect, hasn't it? We talked about architecture, talked about IT, and thanks to Charles for setting up that now we're going to talk about data science. A bit about myself first. My name's Matthew Doubleday. I'm really glad that I can now call myself a data scientist, although at heart I'm a mathematician, and that's what I'll always be. But it's a good arena where I can learn my skills. I've tried to pick up new skills as time's gone by, a bit of programming, a bit of data visualization, hopefully some presentation skills from your point of view. But yeah, let's see, what can a data scientist add to this, and what can a data scientist add to Shop Direct? How many people here know who Shop Direct are? A few. Not as many as perhaps we'd hoped. So let's talk about Shop Direct. So what evidently most of you don't know is that we're a UK company. We're based up in the northwest of England, in Liverpool, Speak. As a company, we've got a long heritage. We've been around in various guises for over 100 years. We're now 100% digital focused. Our heritage is catalogues and books. Now that we're 100% digital focused, we state that we're actually the second largest online pure play retailer in the UK. Our sales are £1.8 billion a year. We have gone through a long period of transition. We're now getting through this and beginning to focus on this online, this digital first focus. And through that transition, there's been a lot of change. From a personal perspective, when I joined the company, the book, the catalogue, the 1,500 pages that we sent out to our customers twice a year, that was the shop. If the customers did not have the book, then they didn't have the shop. It's only, the last catalogues, the last 1,500 page catalogues we sent out were in January this year. We've now stopped doing those. And that's partly because of people in my team, partly because of the change of organisation, and that's that we've managed to prove and have faith that actually the website is now the shop. The catalogue was a marketing material, and was the shop and then changed to be a marketing material, but now that is the shop. So we're now in a period of growth. We've gone through transition. We started making profit. First profit for 10 years occurred in 2013 of £7 million a year. This year it's risen to 71.7, so we're very much a company on the up. Our ambitions now is to transform ourselves into a world-class digital retailer, making good things more accessible to more people. And then I guess that then comes to, well, what can I and the team around me, what can we do to help the company make these good things more accessible to new people and know that we're making it more accessible to new people? Before I get to these charts, let's start with the basics of what a data scientist does, or what I've been doing for many years before it ever got called data science. And to make these charts real, I've got some props. So this is what I've been doing for many years. So say I've got some marketing literature, some nice brochures for Very here. How do I make certain I send it to the right people, the people that are going to respond? Let's say I've got something, here it is. A nice necklace. Perhaps I want to sell it to customers when they get to the till, or the virtual till as it is now. How do I make certain I get the right items in front of the right customers? Perhaps when we're sending items out to our customers, perhaps some items are more likely to get lost in transit than others. How can I identify which items they are so I can introduce remedial measures like a signature on delivery? Or perhaps, and this lost it, it's hooked up. Ignore that. That was going to be a carrier bag. A carrier bag to represent that I was going to be shopping somewhere else. So I'm going to churn, I'm going to shop somewhere else. So can I know who these people are in advance? Can I do something to stop it? So this has been the bread and butter of ops research, data modelers, or now data scientists as we're now called. This has been the sort of problem we've been solving for years. It's a supervised learning problem. You've got something you want to predict, and you've got input variables, and you're trying to predict it. And these charts here are a fairly standardized way of highlighting how well your model of prediction is going to work. So bottom left-hand corner, you're targeting no one, so you're going to get no other people you're trying to predict. Top right-hand corner, you're targeting everyone, you're going to get everyone you're going to try and predict. The aim of the game is to try and create an uplift so you can selectively target people and get more than a random model. So chart on the left-hand side, which is a problem we're currently looking at, If you selected 50% of the people, then you'd probably get about 75% of the people who would have responded, who would have ever responded. So you're getting a reasonably good uplift. So you're not getting 50% by targeting 50, because that's what you get at random. You're getting 75%, so that's good. The right-hand side is an alternative model that was generated a few years ago. 50% there gets you about 82% of the people that would have responded. So that's actually a better model. So I think this echoes, I think, one of the points from the keynotes earlier. What's the difference between the two models? The one on the right-hand side, that's lots and lots of different machine learning algorithms placed at there. There's random forests, there's some boosting algorithms in there. Actually, they all look pretty much muchness to my eye, although there is one that's near the diagonal that's actually quite poor. Whereas on the right-hand side, only one model is applied, but you're getting a much better uplift. I think we touched on data earlier as being important, not just the volume of data, but also the variety. More time was spent on the one on the left-hand side thinking about the problem and trying to understand what is the key data that might influence the problem. On the right-hand side, just took a chunk of data, chucked it at the problem, and chucked a load of algorithms. So key learning from this is think about the problem before you try and solve it. So that's why you need a bit of a human interaction to try and understand how we're trying to solve the problem. But actually it goes beyond that. When we talked about the marketing earlier, trying to get people to respond to a piece of mail, how many of these people responded anyway? So it's not about trying to target the people who responded, it's about trying to target the people who had responded as a result of the marketing. And then that becomes a whole different problem. And a recurrent theme as I go through this in the next 20 or so minutes is that you need to think about the problem. It's not always a simple problem. You need to understand what's the true metric or thing you're trying to solve. So it's going from that descriptive to predictive to prescriptive and analytics, and trying to influence what the customer or the end result that you're trying to influence. So anyway, so that's our bread and butter. Obviously, technology's moved on, and there's a lot more we need to do now. Some of the examples here was about how we get people to the shop. So once you've got people to the shop, a problem that's come around the last few years, particularly as online retail has grown, is how do you reward adequately the influencers that have brought the customers to the shop? So when somebody arrives at your website, they may have come via paid search, they might have come direct to URL, they might have come via an email, they might have seen some display ads. How do you make certain you apportion credit correctly across these channels to make certain you've got your marketing budget spent correctly and you're not over-investing in some channels and under-investing in others? The standard model that I believe a number of companies still use is the last-click attribution model. Effectively, you're rewarding the gold hangers here. You're saying that is the one that's only ever influenced it. So the initial impression here gets no rewards whatsoever. That's probably not great. Alternative ones that can be used. First click. Well, in another way, that's equally arbitrary. That's not actually secured the sale at the end of it. It's had an influence, but it's not actually secured the sale. So there's a range of options you could put in here. Last marketing click, that's perhaps even worse than last click. You're now actually saying that all your marketing is amazingly effective when you could attribute it all to that final point of marketing. Perhaps you could do an average. Again, very arbitrary. Say you increase spend on affiliate marketing. If you increase spend on affiliate marketing, you're going to have more impressions or more leads from affiliate marketing, and you're just going to assume that on average it's performing just as well now when you're spending twice as much on that channel as it was when you're spending half as much. That doesn't make sense. That's not going to work. Another method, perhaps bathtub, last click, first click, perhaps they're the most important ones. The challenge with all these approaches is that they're rather arbitrary and they're not really thinking about the problem you're trying to solve. Going back to the last example, this is actually a supervised learning problem. I've got something I'm trying to predict, I've made a sale, and I've got my inputs. I've got the various touch points of somebody coming to my website or viewing some content that's influenced that sale. So that's another application of data science using data to solve a business problem. And going back to my earlier point, you probably should be thinking about the problem a bit more deeply than this again. Online marketing, it doesn't exist in isolation. Your customers, they're catching buses, they're catching the tube, they're seeing advertising there, they're watching TV, they're seeing above the line advertising, they're on social media. So how do you take it from just being digital attribution to being marketing attribution as a whole? So these are the sort of problems that within our team we're trying to solve. So let's say we've sorted this out. We've now worked out who we should credit for getting a customer to the shop. Where are people once they're in the shop? I was going to put up one of those nice Sankey diagrams that Google Analytics will spit out for you. And then I changed it probably about a month ago when I went to a conference, and somebody highlighted this chart here, which is Napoleon's march to Moscow and back, was arguably the first Sankey diagram. I put it for two reasons. One, because it's a great piece of history and it's a great diagram. And two, because it's actually displaying more information than your standard Sankey diagram you get out to your web analytics tools. In this one, you've got the various touch points, so where people are in their journey, but you also got other dimensions. So you've got temperature on that line bar at the bottom, so adding extra depth and extra information to your journey. So parallel here, but that's one example of how you can visualize where your customers are in the store. Another way of visualizing where your customers are in the store is to use something that's been fashionable relatively recently, is to use sort of like codify up your website and effectively create a DNA of journeys and where people are, and then put these together into strings, or as we have done here, create a blockbuster style diagram and say there's groups of pages that people threw together and these are the paths. The problem with the first one, the Sankey diagram, is you need to be very specific about what paths you're looking at. So if you've not identified the path you need to be looking at, you can't identify it. The problem with the second one is that's not actually very easy to read. It's not very intuitive. There's perhaps other ways, and this is just a conceptualization. As an online retailer, I think there's a great deal of development, progress, further effort that can be done to help visualize how your store is performing. If you contrast it with a retail store, you can stand in a retail store and you can see where there's no stock on the shelves. You could see where there's a dead space in the store. You can see where some tills are busier and other tills aren't. In an online environment, that's a lot harder to see. So creating a template or a way of visualizing the store and making it much easier for your merchandisers, your marketers, and everyone to see how the store is working and then improve it. It's a bit of a holy grail that people are searching towards that I don't actually believe anyone's particularly solved yet. It's something we're working on. But again, another case we need to be thinking about what is the problem. It's not about pathways, it's about understanding your store and understanding how you can improve the store for your customers. So anyway, we've got the customers in the shop. How do we help them find the products they want? So I'm going to give you a little bit of a story here. Who's not seen The Devil's Wear Prada? So you've all seen it? No. Okay, so a few you haven't. Perhaps more because you're shy about putting your hands up. I had my own Devil Wears Prada moment a couple of weeks ago, and I'll explain this to you. So there's a great scene that's stuck in my memory whereby they're dressing a model for a photo shoot, and the assistant holds up these two belts and says, I've got these two belts, I just don't know which one to dress her with. They're so different. To me, they're two blue belts. So I had exactly the same experience myself a couple of weeks ago. Me and my wife were looking for a new blind for the kitchen. We went to a shop, we looked at various blinds for it seems like forever. We ordered one, it got delivered, and she phoned me up and said, they delivered the wrong one. She sent me a text. And I went, she then sent me a text of the one that we did order. So what we got here, in essence, my pattern recognition wasn't great. And there you get to an application of data science in retail, pattern recognition. So at Very, we're using this sort of technology. Snap Style is how we're using it. So if you have the Very app, you can take a photograph of a pattern, we'll recognize that pattern, and we'll try to bring you back items or dresses or clothing that matches that pattern. But that's just one application of how we could use pattern recognition or image processing within retail. This, believe it or not, is a gallery of green dresses. And again, I'm a bloke. My colour recognition is not perhaps as sophisticated as other people's. And I have been assured, actually, these are all different shades of green. But again, if your customer's going to be navigating the shop, perhaps a different way of attributing colour, rather than that rather coarse definition of green, might be better. Perhaps a colour wheel, where the customer can choose a sort of colour that they're looking for, and then you can find colours that match most closely to it. So another case whereby, rather than buying a merchandisers, we could use colour recognition to try and bring back the attributes for the products. But why stop at colour? We could then look at trying to find out, could we define the shape of the dresses? Could we add other attributes to where the customers can navigate the website? And again, provide attributes to make it easier for the customers to find the products she wants. So creating attributes for the customers to navigate the website themselves is one way of making it easier. Personalising it proactively ourselves, so we're actually delivering content we believe she's interested in first to her to make the journey easier, is another. So last example I'm going to go through here is around recommendation solutions. So that's a fairly standard way of deriving a personalisation solution. So here we have a theoretical customer purchasing journey. This one's been particularly active. We've got the products they've purchased, various attributes around the products. And there's various ways you could go about constructing an algorithm to solve this. So your base solution is a basket analysis. If you bought the shoes, these are the items that most likely commonly bought as shoes. That's kind of your base level. Collaborative filtering is perhaps your next level of sophistication up. So not only looking at what you've purchased, but looking at what similar people to you have purchased. So people who are like you who have purchased this have also purchased Y. Or then you get more sophisticated again, and you can start to think about, well, there's actually distance scores involved here. You're quite like these people, and they sort of like these products, and you have bought these products, and these products are sort of like those. And you end up with sort of more of an ensemble model in terms of matching customers to products that's not actually quite as rule-based as the previous two approaches. And this slide here tries to articulate a visualization of how this could work. But again, going back to thinking about what is the problem you're trying to solve, and not just firing a machine learning algorithm that makes certain you're solving the right thing. If we did this in a naive manner, you might find that, yes, the customer in question just then had bought lots of pairs of black shoes and boots. That does not now mean that they need a black tumble dryer. So you need to be thinking about how you're going to categorize and group your data together. And again, you need that human element to try and interpret the problem and then trying to solve the problem as well. So there's countless, I think someone earlier said ideas are cheap. Yeah, there's countless use cases within retail and probably within all your industries too. The key thing I am trying to get across is that you need to have that human interpretation to understand what you're trying to solve and to understand what the best methodologies are to solve it. When you think about big data, it's these use cases that are going to pay for the big data. This is why we're collecting data. It's not just for collecting data's case. It's so that we can actually solve business problems or social problems or whatever your industry is. And I think I'll conclude there. Thank you very much.
Thank you. Okay, 2 questions and then we can all go to lunch.
You brought up the attribution problem before, and you mentioned that...
Yeah.
You brought up the attribution problem before, and you mentioned that you tried to use supervised learning to solve it.
Sorry?
You mentioned the attribution problem.
And supervised learning.
And supervised learning.
Yes.
So is that a fleshed out solution? How did you pick your training data set?
So had to pick the training data set?
Yeah. Because it seems like that would introduce, because the whole point is to decide which channels contribute more towards the conversion or the outcome.
So effectively, if you've collected the data, you've got a whole host of history of what's happened in the past. So you know which channels the customers have seen. So the more you can collect, the more accurate your model is going to be. So if you collected where the interactions are in the past, where they've seen adverts, etc., there's a number of approaches creating your training, test, and validation data sets. You could just split your data 50-50 or 40-30-40 to create training, test, and validation if that's how you want to do it. Or you could use it in time periods. In essence, it's a relatively traditional way of splitting historical data to then inform future predictions. The thing about the attribution modeling example in particular is that you really want to be thinking about a feedback loop and make sure that it really is a machine learning algorithm, and when you do bring on new channels and you do change your marketing spend, that it adjusts accordingly. Does that answer your question?
Sort of, but we can
Yeah.
take it offline now. I can ask you more detail.
Okay.
One other question over there. Okay. Thank you.
I've got a question about putting the results back for a human interpretation, because we have many different models, from really simple regression models to really black box deep learning models. So from my experience, the middle ground would be some kind of random forest that is still open to interpretation, that you can share results from it, and you know what you can output from it later to the business. What's your take on actual constructing the model for the business and getting the knowledge out of it?
That's going to definitely depend on your business problem and your stakeholders. So actually, in some cases, I'd almost regress to just doing a standard classification tree. Perhaps it's a case of we need to identify distinct groups of customers that we're going to do distinct actions on. In that case, anything relatively sophisticated, like a random forest or even a linear algorithm, is not going to solve that particular problem. In other cases, particularly recommendation solution, that's still relatively black box. So you need good stakeholder buy-in. You need to develop trust with your stakeholders that they actually can believe, and then you need to prove your results. A/B testing on your website, or multivariate testing website, to prove that you got benefit, you delivered the benefit. But it really does depend on the problem and your stakeholders.
Okay, thank you. Thank you, Matthew. I
Thank
think
you.
the fact that the room is still full